Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Negative Constraints Galore by Oatmeal. And here we're going to explore essentially what negative constraints mean and what they imply for the puzzles. Let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have digits separated by a black dot are in a 1 to 2 ratio, and digits separated by a white dot are consecutive. All dots are given. So that means the negative constraint applies. So this is the first negative constraint here. Actually, I think this is the only negative constraint we have. Yeah, that's the only negative constraint we have. So that's why it's the negative constraint. Well, it should be negative well, it is negative constraints because it's both the black dots and the white dot. We only have one white dot here. Oh, I was gonna say the X's would be interesting, but if they had a negative constraint, but there is no negative constraint for the X's. That's too bad. Because I guess there are two negative constraints. It's not the negative constraints themselves aren't there isn't a galore amount of them. there's only two of them. But they are throughout all the puzzle because there's only one white dot here and there's no black dots. So that means no two cells which share an edge in this puzzle are in a 1 to 2 ratio. And the only digits which are consecutive are these two digits. And say if this was a 6, this would have to be a 5 or a 7 because this dot means that these digits must be consecutive. But it also means these two cells cannot be 5 or 7 because there is no white dot between them. And we know all dots are given. So that is what the negative constraint means. We have digits along a thermometer must strictly increase starting from the bulb end. So as an example, you could have something like 2, 4, 5, 9. That would be valid because you're continuously increasing from the bulb to the tip. You cannot have something like 2, 6, 5, 9 because it's decreasing from the 6 to the 5. We have digits in a killer cage must sum to the value in the top left of the cage. So for example, if this were say a 4, this would have to be an 8 because these two digits must add up to 12. We have digits separated by an X sum to 10, but not all X's are given, so there is no negative constraint here. And what a negative constraint means is that basically the absence of a clue is an actual clue itself. That's what it means. So say we had a 4 here. This would have to be 6 to add up to 10. And finally, we have digits along an arrow must sum to the value of the digit in the circle. And since this is the only arrow, well, if this was 4, this would have to be 4 too, because these digits, the sum of the digits along the arrow must sum to the digit in the circle. Since this is one digit, it must be exactly the same digit as that. And therefore, we know that the X constraint cannot be because of this. This would also have to add up to 10 too. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's look at the long thermometer, since that gives us the most information. What I like doing for long thermometers is looking at the bulb, looking at the lowest digit possible, and going along all the way to the tip, looking at the lowest digit possible along each cell. Then I like looking at the tip, going from the tip to the bulb, looking at the largest digit possible, and then restricting the digits in the cells for those digits. So this could be 1, because that's the lowest digit possible in Sudoku, in normal Sudoku. This cannot be 2 because it's in a 1 to 2 ratio with 1 and it's consecutive with 1. So this has to be at least 3 because it must be greater than 1 because it can't be the same. This digit, well, it could never be the same. It must always increase. This digit is greater than that. It could be 4. This digit is greater than that. It could be 5. This digit is greater than that, but cannot be consecutive with it, so it must be 7 at least. And this digit is greater than that, so it's 8. Greatest digits here could be 9, because that's the largest digit in normal Sudoku. That's the largest digit in Sudoku. This digit must be less than 9, so it's 8. This digit cannot be 7, because 7 and 8 are consecutive, so it could be 5 or 6. This digit could be 5, this digit could be 4. This digit cannot be 3, because 3 would force this to be 4, and therefore they would be consecutive. So this is 1 or 2 here. Okay. These two digits add up to 12, and they cannot be in a 1 to 2 ratio, so 4 and 8 are eliminated. So it could be 3, 9, or 5, 7 here. These digits add up to 10. That doesn't really tell us much. Let's look at this. So 1 can be 2, 3, 4 at minimum, 9, max 8, 7, 6. So this is 1 through 6, 2 through 7, 3 through 8, 4 through 9 here. Okay. So we've used up pretty much everything except the negative constraints. One thing, so in the central box, this digit cannot be 3, 4, 5, or 6. If it was, if this was 3, that would force this to be 4, and they would be consecutive, and they don't have a white dot between them. Same with this 4 and being 5 or 3. Same with 5 with being 4 or 6 here. So this is 1, 2, 7, 8, or 9 here. This digit cannot be 1 or 2, or 7 or 8, because then they would be consecutive, guaranteed. So this is 3, 4, 5, 6, or 9. So these digits cannot be 3 or 4. 3, 4, 5. So this is 1, 2, 6, 7, 8, 9. This digit can't be 4, 5, or 6, so it's 1, 2, 3, 7, 8, 9. Interesting. This digit cannot be 7 or 8. So it could be 1 through 4, 6, 9, which adds up to 1, 4, 6, 7, 8, 9. So this is 1, 2, 3, 4, 6, and 9. Okay. What does that mean? I'm not quite certain. I just started this because this was interesting to me, but 3 we know has to be one of these 3 cells. 4 has to be one of these 3 cells. 5 is one of these 3 cells, and 6 is one of these 3 cells. Okay. Oh, this can't be 9 either. If this is 9, then that would be guaranteed to be 8. which would be consecutive. So this cannot be 9, which means this can't be 1. This can't be 9 again. Oh. If this is 2, it would be consecutive with 3 and in a 1 to 2 ratio with 4. So this cannot be 2. This is guaranteed to be 1, which eliminates 1 in the rest of the box and the rest of the column. So this cannot be 1 and 9. This can't be 1. That's interesting. 2 is one of these digits. 9 has to be one of these 4, but that doesn't really tell us much. If this is 6 here, this would have to be 5, 4, and 3, and 3 and 6 would be in a 1 to 2 ratio. So this cannot be 6 here. Okay. If this was 4, this would force this to be 5, 6. This could be still 7 or 8, so that's still fine. Oh, 2 has to be one of these 3 digits. Well, 4 is guaranteed to be in a 1 to 2 ratio with 2. So if this was 4, you would guarantee to have a black dot in between, which we don't. So this cannot be 4. This is 5, which forces this to be 6. 6 cannot be in a 1 to 2 ratio with 3. So this cannot be 3 here. We have a 2, 7, 8, 9 quadruplet in the central box, which eliminates 2, 7, 8, 9 in the rest of the box. This can't be 5, 6, or 9, so it's 3 or 4 here. If we had a 2 here, it would be guaranteed to be next to a 3 in one of these boxes, and that doesn't have a white dot in between. So this cannot be 2, which means 2 has to be one of these 2 digits here. 5 eliminates 5 here, so this cannot be 7 then to add up to 12 with it. This is 6, so this can't be 7. This is then 8, which means this can't be 8. That's 9. So there we go. So this is not 8. There's no more 8 in the box. This can't be 2, 8 because of the 8 in the column. 8 cannot be in a 1 to 2 ratio with 4 next to it, so this is 3, which makes this 4. 2 cannot be here because it's next to 3 or 4, which it's a 1 to 2 ratio or consecutive with, so this is 2. This can't be 3. And if you had a 4 here, that would be in a 1 to 2 ratio with 8. So this has to be 6 and 4, which makes that 6. 7 cannot be consecutive with 7 is consecutive with 6, so it can't be next to it, so that's 9 and 7. This can't be 9 anymore, and this can't be 3 because of that. This can no longer be 6. There's no 4 or 6 here, no 4 or 6 here. Remaining digits in column 4. We have 2, 5, 7, 9. Not 3, 5, 7, 9. 2, 5, 7, 9. 2 cannot be here because of the 1 to 2 ratio between the 1. 2 can't be here because of the 1 to 2 ratio between the 4. So this is guaranteed to be 2 here. Also, if this is 5, 7, that would force this to be a 2, 9 pair for 3 cells, which is not allowed. So this has to be 3 and 9, which is eliminating 9 in the rest of the box. 2 cannot be consecutive with 3, so this is not 2, which makes this a 2. That means this has to be 9 because of the 5, 7 pair in the column. Remaining digits in this upper central box. Excuse me. Upper central box. We have 1, 4, 6, and 8. 4 and 6 cannot be here, so it's a 1-8 pair, but 1 can't be here because that's consecutive and in a 1-2 ratio with 2. So this is 8, this is 1. We have 4 and 6 here. 4 cannot be in a 1-2, cannot be consecutive with 8 because of the 1-2 ratio, so this is 6, that's 4. This pair, to be consecutive, has to have an even digit, right? You have to have even and odd digits, right? Because those are the only consecutive digits you can have. And we have 2, 6, and 8 here. So this cannot be 2, 6, or 8. It's 4. And it's either 3 or 5 here. Well, 3 is in a 1-2 ratio with 6, so it can't be there. 5 is consecutive with 6, so it can't be there. So this is 4, which means this cannot be 4 here. Remaining digits in column 5 are 2, 5, and 7. 5 and 7 are both consecutive with 6, so this must be 2. 5 is consecutive with 4, so this must be 7, and this must be then 5. Remaining digits in column 6 are 1, 3, and 8. 1 and 3 are consecutive with 8, 2, so this is 8. And 1 and 3 can be in any ratio here. Okay. What else? This cannot be 2. So since this can't be 2, this can't be 3, that can't be 4. This can't be 5. This can't be 7 anymore. This can't be 9 because of the 9 in the row. So this digit must be smaller than this. If this is 8, it's not going to be. So this has to be a 5. So this is 5, which forces this to be 3 or 4 to be less than it. This has to be 1, 2, or 3. If this was 2, it's guaranteed next to be consecutive or adjacent to a consecutive digit with 1 or 3. So this can't be 2. This is a 1, 3 pair. That leaves the remaining digits in row 8 as 2, 8, and 9. 2 again cannot be here because it would be adjacent to a consecutive digit out of 1 or 3. So this is 8 or 9. This is 2, 8, or 9. This cannot be 9 here. So this is a 2, 8 pair, which eliminates 2 and 8 in the rest of the row. So this is 9 then. 8 cannot be consecutive adjacent to a 9. So this is not 8. Let's see. Remaining digits in row 7. We have 1, 3, 4, 5, 7. Okay. 5 cannot be here. 1, 3, 4, 7. So this cannot be 4 because that's consecutive with 5. If this was 3 or 4 here, okay, so this can't be 1 or 3. This could be 1 or 3. This can't be 3 or 4 because if this was 3, that would force this to be 4, and they would be consecutive. So this is 1 or 7, and this is 1, cannot be 3. So this is a 1, 7 pair, which eliminates 1 and 7 in the rest of the row. So 5 has to be here. If you had a 4 also here, that would be consecutive, so that's not allowed. So this has to be 3 and 5, which eliminates 3 and 5 in the rest of the row. So this is 4. This is a 1, 7 pair, which eliminates 1 and 7 in the rest of the box. So this is 6. This 1, 7 pair eliminates 1 here. So this is 3, which makes this 1, which makes that 3. We have only 2 and 8 remaining in this lower right-hand box, and 2 is consecutive with 3. So this is 8, this is 2. Remaining digits in row 9 are 1, 4, and 7. 7's consecutive with 6, so this can't be 7. Okay. Where do we continue? We have 1, 3, 5, 7, 9 remaining in row 1. Those are the odd digits. This can't be 9. This can't be 1 or 3 because they're consecutive with 2. 1, 3, 5, 7, 9 cannot be 5 because of 5 in the column. Okay. What else do we have? Remaining digits in column 8. Shall we try that? We have 1, 2, 3, 5, 7, 8. This cannot be 2 or 8. 3 cannot be 3 or 5 because that's consecutive with 4. No 3, 5 here. No 1 or 7 here. No 1 here. No 3 here. Okay. I don't know if that's that helpful. Interesting. uh, um, hmm. Yeah, we're just really using the negative constraints here a lot. Remaining digits in column 7. We have 1, 2, 5, 6, 7, 9. This can't be 2 or 6. No 5 or 9. No 1 or 7. No 1. No 9. This digit cannot be consecutive with 4 or in a 1 to 2 ratio, so no 2 or 5. This digit cannot be in a 1 to 2 ratio or consecutive with 4, so no 2 or 5. This can't be consecutive with 7, so no 6. No consecutive with 5, so that can't be 6. Can't be in a 1 to 2 ratio with 2, so it's no 1. If this were a 1, that would guarantee 2 would have to be here. So 2 has to be one of these two digits. Can't be here because that's the 1 to 2 ratio with 4. Can't be here because 1 to 2 ratio with 4. Can't be here because 2 in the region. And it just can't be here. So 2 has to be one of these. So this cannot be 2 here. Which means 2 has to be one of these digits here. If this were 1, that would force this to be 2. And that would be consecutive and adjacent, which is not allowed. So this can't be 1. Same with this 1. Same with this 3. Everything else seems okay. Where is the 6 in column 7? Can't be here because of the 6 here. Can't be consecutive with 5. Can't be consecutive with 7. So it has to be one of these two digits here. So if there was a 7 here, that would guarantee that the 6 is next to it and they're consecutive. That's not allowed. So this can't be 7, either of those. Interesting. Mm-hmm. Hmm. 1 has to be one of these two digits here. Because there's no other place for it in column 8 anymore. Can it be there because of the 1? And if it's one of those two, it's consecutive with 2. That's not allowed. Hmm. Remaining digits. This is kind of painful, but remaining digits in column 9. We have 1, 3, 4, 6, 7, 8, 9. So no 3, 9. These cannot have a 6 in it. No 1, 4. No 4 here because of the 4 in the region. No 1, 4, 7. No 3 or 9. No 6 or 8. Okay. We know 6 has to be one of these two digits. So again, you can't have a 7 there. You can't have a 3 here either, because that would be in a 1 to 2 ratio with the 6. So there's no 3 or 7 there. Yeah. Remaining digits in row 6. 1, 3, 4, 5, 7, 9. So no 9 here. No 7 because that's consecutive with 8. No 4 because that's in a 1 to 2 ratio with 8. 4 cannot be either of these cells. Okay, there we go. 4 cannot be either of these cells because they're consecutive with 3 or 5. So where's the 4 in row 6? Cannot be any of these cells, so it has to be here. So this is 4, which means 4 cannot be here. 8 cannot be here because that's in a 1 to 2 ratio with it. So this is 1 or 6. Okay. We know 3 has to be one of these 3 cells here because it cannot be here because that would be consecutive with 2. Cannot be here consecutive with 4. So where is the 3 in box 6? Or this box, this right central box? Can't be here. Can't be here because it'd be consecutive with 2. Can't be here because consecutive 2. Same here. 3 would be in a 1 to 2 ratio with 6, so it has to be here. So this is 3, which means this cannot be 6 because that's in a 1 to 2 ratio with it. So 6 in column 9 has to be here. That's consecutive with 7, so that can't be 7 there. 3 is consecutive with 2, so this can't be 2, which forces this to be 2. 3 eliminates 3 here, so this is 5, which eliminates 5 here, so it's 7. This can't be 5 or 7. No 7 here. No 5 here. 2 is cannot be consecutive with 1. Or it cannot be adjacent to 1 because they're consecutive. So this is 6. This is 9. This is not 1. So this has to be 1 here. There's no other place for it in this right central box. So that eliminates 1 here. This is a 7-8 pair, which eliminates 7 and 8 in the rest of the box. This can't be 9 either, so it's 3. 8 is consecutive with 9, so this can't be 8, so it's 7. This is 8. 7 eliminates 7 here, so it's 5 and 7. 8 eliminates 8 here, so it's 9. 1 eliminates 1 here, so it's 7, which makes this 1. 7 eliminates 7 here, so it's 1 and 8. 8 cannot be consecutive adjacent to a 7 because they're consecutive, so this is 2. No 2 or 9, so it's 5. No 5 or 9, so it's 7. Okay, so this cannot be 1 or 7. This is 3, 5, or 9. Remaining digits in row 4, we have 2, 6, and 8. 2 cannot be here because of that's consecutive with 1. 6 can't be here because of 6 in the column, so this is 8, which eliminates 8 here. Remaining digits in row 2, we have 1, 4, and 5. Well, 4 and 5 are consecutive, so if 1 is on the corner, 4 and 5 would have to be next to each other. So 1 cannot be in on the edges, 1 has to be between them. So this can't be 1. This is a 4-5 pair. Remaining digits in row 3. We have 2, 6, and 8. This can't be 6 or 8 because of 6 or 8 in the column, so this is 2, which means neither of these are 2. This is 6, 8 as a pair. Remaining digits in row 5. We have 1, 4, and 7. 7 can't be here because of 7 in the column. This can't be 1 because of 1 in the column. We have a 1, 4 pair in column. And this can't be 4 because it's consecutive with 3. So this is 1, which makes this 4, which makes this 5, which makes that 3. So there's no 3 here. 1 cannot be here. This can't be 4. 1 eliminates 1 here, so this is 7. That's 1. 8 can't be adjacent to a 7, so this is 2. That's 8. 3 can't be adjacent to a 2, so that's 5 and 3. 5 eliminates 5 here, so it's 9 and 5. 2 eliminates 2 here, so it's 6 and 2. 7 eliminates 7 here, so it's 4 and 7. 6 eliminates 6 here, so it's 8 and 6. 5 eliminates 5 here, so it's 4. 9 eliminates 9 here, so it's 3. And let's just check to make sure. 9 is not consecutive with 3 or 4, and it's not 1 and 2 ratio. So 5, 7, and 9s are going to be different. 9's not consecutive with 3 or 4. 7's not consecutive with 3, 5, or 2. 5 is not consecutive with 4, 2, 1. 9 is not consecutive with 3, 4, 6. 7, no for 2, 3, 5. 5, no for 1, 2, 7. 5, no for 1, 2, 7. 9, no for 5, 6, 7. 7, no for 2, 3, 9. 9, no for 3 and 6. 5, no for 2, 3, 7, 9. 7, no for 4 and 5. 7, no for 2, 4, and 5. 9, no for 3, 4, 5, 6. 5, no for 2, 7, 9. 7, no for 1, 2. 9, no for 3, 4, 5. 5, no for 3, 7, 9. 5, no for 2, 3, 9. 9, no for 3, 6, 5. 7, no for 4 and 5. 5, no for 7, 9, 2. 9, no for 3, 4, 5, 6. 7, no for 1, 2, 4, 5. 7, no for 1, 2, 4. 9, no for 4 and 5. 5, no for 3, 7, 9. Okay, now the rest. 3 is not consecutive with 1, 7, or 9, and not in a 1 and 2 ratio. So 3 must avoid 4, 5, 2, 4, and 6. 2 must avoid 1, 3, and 4. 8 must avoid 7, 9, and 4. 6 must avoid 5, 7, 3. 4 must avoid a lot. This is consecutive with 5, but we have a white dot there. Cannot be normally 3, 5, 2, or 8. 1 can only just needs to avoid 2. Oh, I guess we could have 1s also. 1 is not touching 2. No 2. No 2. No 2. No 2. No 2. We should do it this way. No 2. No 2. And no 2. 2s must avoid 1, 3, and 4. No 1, 3, 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 4. 3s must avoid 2, 4, and 6. No 2, 4, 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 6. And no 2, 4, 6. 4 must avoid 2, 3, 5, and 8. Except for the consecutive one. So this has a 5 here, but no 2, 3, 8. This is 9, so no 2, 3, 8. 2, 3, 5, 8. No 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 2, 3, 5, 8. And no 2, 3, 5, 8. 6 must avoid 5, 7. So 5 and 7 are already accounted for because we checked all the 5s and 7. So we just can't have a 3 next to it. No 3, 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 and no 3. And then 8 cannot be next to 7 or 9, but we've checked 7 and 9s. So just have to check them for 4s. No 4, no 4, no 4, no 4, no 4 here, no 4, no 4, no 4, and no 4. So this should be a 9. And that's the solution to this puzzle. I hope that actually made a lot of sense. We obviously did use the negative constraints galore, but there weren't that many negative constraints there, just the 2. But that did restrict a lot of things, so maybe that was sufficient. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.